Let's have a look at another question here where we actually have to work backwards. So in 18 years time, I want my investment to be worth $30,000. So in 18 years time, I want to have $30,000 in my bank. Okay? If the interest rate is 6% per annum, compounding yearly, so that's fine, it's in years, how much should I invest now? So how much should I put into the bank now? So in 18 years time, I have $30,000. Let's just start by writing the formula. A represents my total amount after a certain amount of years. So this A is $30,000. Okay, it's not the principal. This is my question. That's the question, how much should I invest now? So I'm going to just write that as P because that's what we're trying to find out.
Bracket 1 plus.
My rate is 6% to the power of the number of years is 18 years. So what I want to do is I want to know what that number is itself because it's multiplied with the P. This number rounded to 2 decimal place is 2.85. Okay? And this is how you would find P. What do I need to do? Just divide it across.
So P is equal to 30,000 divided by 2.85.
That will give you the amount for P. And that is $10,526.32. So this is how much I need to invest now in order to get $30,000 in 18 years' time. Depreciation is basically when you buy an object and it loses its value over time. But when you buy a car, in 5 years' time, it's not going to be worth the same amount that you purchased it for because there are a lot better newer cars, right? So there's actually a formula to actually calculate how much something is worth after a certain amount of years. It's basically the same thing as a compound interest formula. The only difference is it's got a minus, okay? So it's not a plus. So it's the same thing. All right? So if I was to just write it, this represents how much. All right, so let's put this formula into an actual example. So we have here, Danny has spent $12,400 in equipment, okay? The equipment depreciates at 15% per year, so it goes down by 15% every year. Find the value of the equipment after 4 years. All right, so we want to know how much it's worth after some time. So this is the question. Your A, when your starting value P is 12,400, bracket 1 minus the rate is 15%.
15 over 100.
To the power of the number of years is 4 years.
Alright.
So if I put this in the calculator, I get $6,472.88 after 4 years. Okay? It says find the amount of depreciation after 2 years. Okay? That doesn't mean how much it's worth after 2 years. That means they want you to find out how much it went down by after 2 years. So you still got to do the same thing. Let's find out how much it's worth after 2 years, okay? Remember, my starting value is 12,400. That will never change. Bracket 1 minus, that will never change as well. The rate of depreciation, 15 over 100. But the number of years is different. We want to know how much it's worth after 2 years, so that's the power of 2. So after 2 years, you'll be worth $8,959. However, what we want to know is how much it went down by. So the amount of depreciation after 2 years is how much we purchased it for in the beginning, take away how much it's worth after 2 years. So how much did it go down by? $3,441. Okay, that's my final answer. By trial and error, how long will it take for that equipment to be worth just under $3,000? Answering exactly years and months. Okay, so in order to do that, let's just write down the formula. Okay, let me write down what the question wants. What they want is I want this total amount to be just under $3,000 when the principal is still the same. That's my starting value. That's still 12,400. Bracket 1 minus. My rate is still the same as well, 15%. But the question is, what number do I need here? That's my question there. What number do I need to plug it in here? So if I put that in the calculator, the number on the other end is just under $3,000. So let's use trial and error, which means guess and check, to see what that n might be. Let's try n equals to, let's try n equals to 7. So if I plug that here, and if I plug in 7, let's see what number I get. $3,975.50. 16 cents. Okay, that is close to 3,000, so our first try was pretty good, but because I need this to be a smaller number, that means I need to try a bigger number here. Okay, let's try 8. Okay, and let's see what we get. $3,378. That's still not under 3,000. Let's try 9. Okay, I get $2,872. That is under 3,000, but they want it to be just under 3,000, and we can be more exact with this because they want it in years and months. So what I'm going to do is, instead of 9, let's try 8.5. Okay, $3,115. All right, we're getting very close to 3,000, but it's not under 3,000. That means what I want to do is I want to get a higher number than 8.5. Let's try, oh, it's still not under 3,000. I get 3,064, very close, not that. So I'm pretty sure then that means my answer has to be 8.7. Surely that's just got to be under 3,000, okay?
So if I try that?
No, it's not. Ooh, you know what? It's not 8.7 either. It's actually 8.8. All right, so if I put 8.8, that gives me $2,966.94. That is the most accurate answer that I can get in terms of the months. Because if I put in 8.9, that's, oh, actually, yeah, if I put in 8.9, I get 2019. 2,966, that's the lowest number, just below 3,000. So that's my answer. But we're not done yet. It says 8.8, we want it in years and months. So we know this means
8 years, but
how many months is 0.8? All you need to do is just basically do 0.8. If you times that by 12 in the calculator, you get 9.6. So you want to just take the number itself and write that as months. You don't want to round it up to 10.